Hello everyone, today we're on 10-7 area of triangles and trapezoids on page 284 in the green book. We have 4 objectives here. We're going to use the formula to find the area of the triangle, use a formula to find the area of the trapezoid. We're going to rename area units in equivalent terms, and then find an unknown base or height given the area of a triangle or trapezoid. Okay, so let's do the area of a triangle first. So area equals 1/2 times base times height. Okay. My base is going to be right here. You can see it. Okay. Now the base of a triangle can be any one of its sides. Okay. The altitude, which will be right here. I'm going to do that in purple. It's going to be right here. Okay. Just like with parallelograms, the height or the altitude may be determined by dropping a perpendicular line segment from a vertex to an extension of the base that is opposite of the vertex. So we start at the vertex right here. That's our vertex. And we're just going to drop it down right here. Straight down. Okay? So this is our altitude. Remember, the altitude, what can I spell? The height is the length of the altitude. Okay? All right. So again, we're doing area of a triangle, so it's 1/2 times base times height. So let's say that the base is going to be 12, and the height, let's say, is going to be like 13. We'll just do that. It'll be easy. Okay. So we're going to do area, wrong one. Area equals 1/2 times base, which is 12, times height. All right, so don't type. Let's do that in your notebooks, and then hit play whenever you're ready to check your answer. Okay, so the area for this particular triangle, which I forgot to tell you that this triangle's name is Trudy the triangle, just in case you cared. So our area here is going to be, I believe it's 78. Let's just say that we use centimeters. Boom, 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 boom. So 78 centimeters, and let's say, remember, area is always squared. So it'll be 78 centimeters squared. Okay? All right, let's jump over to area of trapezoids now. Okay? So the area of a trapezoid is going to be 1/2 times base 1 plus base 2 times height. Okay? So let's talk about where the bases are. Your bases are going to be the 2 pairs of parallel lines. Now, right here we have 2 horizontal sets of bases on this trapezoid, but they could be vertical as well. But they will always, your bases are always the 2 pairs of parallel lines. Okay? So right now we have base 1 up here, base 2 down here, and here's your height. Okay? Now you draw your height on a trapezoid, okay, from one of your vertexes down to the opposite base. So right here, let me do this in a different color. It's too blue. Right here, you could also draw it right here. This is another one of your altitudes or your heights. Okay? So remember, 2 bases are your 2 pairs of parallel lines. Your height can be drawn from one vertex down. All right, let's try out this bad boy. So right here we have this trapezoid of a base 1 is 7.4 millimeters, base 2 is 13.6 millimeters, and our height is 7 millimeters. So let's set this nugget up. So we have area equals 1/2. Base 1 is 7.4 plus base 2, which is 13.6, all multiplied by the height of 7. Okay? Alrighty, so we're going to add these two together first. 7.4 plus 13.6 is going to give us 21. So we have area equals 1/2 times 21 times 7. Okay? I'm going to multiply these guys together first to give it an easier number in my head. 21 times 7 is going to be 147. So we have 1/2 times 147, which is going to give us 73.5. Our measurement is millimeters squared. Okay? That's it. That's all she wrote. Just remember that these right here, this side and this side, are not your bases because they are not parallel lines. Okay? Alrighty. Okay. If you know the area of the trapezoid or triangle and either the base or the height is unknown, you can use an area formula to find the unknown dimension. So you're kind of going to use and break it down like an algebraic equation. So if I know that my area is going to be 184 feet altogether, and I know that one base, or base 2, is going to be 17 feet, and I know that my height, the length of my altitude, is going to be 16 feet. Okay, I'm going to plug it in right over here to this equation. So we know that area is 184 equals 1/2 times B1, or x. You're going to rename that as B1, okay? B2 is 17 and my height is 16. So I'm going to rearrange it so it looks like this. 184 equals 1/2 times, I'm going to pull this 16 and then I'm going to distribute, the x, or the 16 across the x and the 17. So that's going to be 1/2 times 16x plus 17. Nope, not plus 17, plus 16 times 17, which will be 272. So, here we go. So we now have 1/2 times 16x plus 272. So we're going to 184 equals 1/2 of 16x is going to be 8x, okay? Plus 1/2 of 272 is going to be 136. Okay, I'm going to subtract 136 on both sides. Cancel that out, so now it's going to equal 184 minus 136. It's going to be 48. So 48 equals 8x. Divide by 8 on both sides. Okay? X is going to equal 6 feet. So that's really base 1, because that's what we were looking for originally. So our base 1 is going to be 6 feet. And that's it. Okay? You're basically just substituting in numbers for the values that you already have, and then solving for what you don't have, or the unknown. Okay? That's it. I'm sorry this was a little confusing. I tried to fit in too much into one little box. Okay. Alright, you can also rename the area of a figure by finding its equivalent in different units. So, as just a reminder, 1 centimeter equals 10 millimeters. If you multiply that together, you're going to get 1 centimeter squared, which is what we're looking for in area. So if you have 1 centimeter squared, that is equivalent to 100 millimeters. Okay? That's just a quick overview of what we're going to be doing in class. Alright, you're going to try these numbers 1 through 6 in your notebooks. I'm expecting to see all those complete. Okay? I'll see you guys next time in class. Adios, amigos.